How's it going, guys? Mr. Lustelo. This is the second part of your assignment for the day, here with Mr. Howard, 5721. And we're going to talk about Punnett squares. So this is named after the guy who invented it. His last name was Punnett. Before we do that, you're going to watch this quick video here. This is going to talk about Gregor Mendel. He's known as the father of modern genetics. If you remember from my class or from a physical science class you took about Isaac Newton, he's the granddaddy of physics. And so this guy is our biology guy, Gregor Mendel. He figured out all this stuff about genotypes, phenotypes, dominant traits, recessive traits, how those traits are passed on. So real smart guy. You'll watch in this video, talk about how he figured that out. In this video, you'll learn about Punnett squares as well as heterozygous and homozygous traits. That's what the second part of this assignment is going to be. So pay attention to those when you hear about them. But let's take a look at Punnett squares first. So Punnett squares are a tool scientists use to predict genetic crosses. They're a simple way to make predictions about the offspring of two parents. So we're going to take two fictional parents and say what would happen if these two had a baby. So if you know the genotype of the two individuals, we can make these predictions. So we got to know the genotype, not just the phenotype. Remember, genotype is the combination of alleles, so it's your actual genetics. Capital B being dominant, lowercase b being recessive. We have the combinations double capital, double lowercase, or a mix of both, capital and lowercase. Those are genotypes, whereas phenotypes are what you see, right? Things like when I look at you, do you have brown eyes or blue eyes, curly hair or straight hair? Those are your phenotypes. So in the example we're going to look at these individuals. Our dad has BB capital. I will add this post video. This will be a post video edit, but we're talking about eye color here. I should have specified that a little bit better. So we're talking about eye color, where brown is the dominant allele and blue is the recessive allele. We've looked at this exact combination a few times in past assignments, just never put it into a Punnett square. So dad is BB with brown eyes, double dominant. Mom is BB, double recessive with blue eyes. So I'm going to hop over here real quick and show you how we're going to make the Punnett square in paint. Spoilers right there a little bit, but you'll see how I put that all together. So remember, dad is our BB. Mom is our BB, this one. So as we... hold up, guys. Mr. Ontiveros walked in. You're good. I'm just recording. You can stay. I'll be done in 5 minutes. You can stay. If you guys have Mr. Ontiveros, he just walked in. That's the homie. So just give me a second. So what are we going to do? We're going to take these crosses and we're going to put them into our Punnett square right here. Here's the thing. See, a lot of people do this when they're building a Punnett square. They put one there and one there, and they go, Mr. O, what'd I do wrong? Well, what you did wrong is when we're setting up a Punnett square, we got to separate the alleles. So we got to separate one B over there, one B over here, right on the top. Always start at the top. Second one goes to the side. You can put it here or here, doesn't make a difference. I always put it on the left. That's just how they're normally drawn. If you're feeling crazy and you want to put it on the right, that's okay. It'll all end up the same. But so when we get our cross, we're going to put two of dad's alleles, one on the left, one on the right, and mom's two alleles, one on the top, one on the bottom. I'm going to flip back here now, and you can see it's exactly what I got here, right? Oops, and sorry, I must have copied the wrong example, but the thought's still there, right? In my other example, this was a capital B, but this is the correct Punnett square right here, right? Dad is double B, capital, mom's double B, lowercase, and so we got the Punnett square here. Now, you're going to cross the genetics by filling in the boxes with the letter from the top, right? You see this capital B's on the top, so I'm going to fill in these two boxes with a B. I'm going to fill in these two boxes with a capital B. I'm also going to go to the right with it. Here, lowercase b, and here, lowercase b. You'll see a better example of this in action in the video, but hopefully these images help you too, right? So you can see I did that here. The B from the top filled in both of these. The B from the left filled in both of these. And when I put those two images together, we have a completed Punnett square. So this would be a completed Punnett square. BB, all to the top, lowercase b is going to the right. And so this box, you want to look at each box individually, right? This box has this capital B, this lowercase b. This box has this capital B, this lowercase b. And these four boxes are the possible offspring of these parents. So as you can see, the child of these two, a dad with double B, brown eyes, and a mom with double B, lowercase, blue eyes, will always have children with the genotype capital B, lowercase b, capital B, lowercase b, every single kid. And because of that, every single kid will have brown eyes. Because remember, dominant traits, you only need one letter to have that trait. The only way to have blue eyes is to have lowercase b's. And so if you guys remember, I believe it was Emily, I can't remember exactly, but somebody said, I told you you're the rare case where either both your parents have brown eyes, yet you have blue eyes, or the case where one parent has brown eyes and one parent has blue, but you have blue eyes. Because we can see here, that didn't happen, right? Even though mom's got blue eyes, none of her kids will ever have blue eyes, ever, because dad is always going to pass on this dominant B. What about this example? Dad, brown eyes, double B's. Mom, brown eyes as well, but she carries that blue gene. We're going to do the cross, right? My B's from the top, fill in here. My B's from the side, fill in too. When you cross this one, you get double capitals, double capitals. This one I get one capital, one lowercase, one capital, one lowercase. And so in this case, again, all kids will have brown eyes, but two will be double B's, capital, two will be one capital, one lowercase. And so this is, okay, here's the example I was just talking about. Look at this cross. Dad's got brown eyes, mom's got blue eyes. Sorry, brown eyes. Both have brown eyes, but both carry the gene for blue eyes. They carry it, but they don't display it, right? Their genotype has a blue eye gene, but their phenotype is still brown. When we cross these, look what happens. B and B, brown eyes, double dominant. B and B, brown eyes, one dominant, one recessive. B and B, one dominant, one recessive, brown eyes. But what about this box? Double lower cases, right? So this is a dad with blue eyes, a mom with a dad with brown eyes, a mom with brown eyes, and they have a blue-eyed baby, right? So back in the day, this was like the whole, are you cheating on me? Right? Baby gets born and mama slaps the dad, right? Because the baby's born with blue eyes, right? But that's possible. It's possible for two brown-eyed people to have a blue-eyed baby if they're both carriers of that gene. So it sounds strange to say that two brown-eyed parents can have a blue-eyed baby, but a brown-eyed dad and a blue-eyed mom sometimes can't. Because if dad doesn't carry that side blue gene, then they can't ever have a blue-eyed baby. Which gets us in to those two words I spoke of earlier, homozygous and heterozygous. Right? So we're looking at the same traits as before, eye color, where B brown is dominant, B blue, lowercase, is recessive, which means we have three possible combinations, right? Capital, capital, lower, lower, or the combo. Both genotypes, capital, capital, and capital, lowercase, will produce the phenotype brown eyes. This is what we've been talking about, right? It's a dominant trait. You only need one. You're going to have brown eyes. We have seen though that even though the phenotypes are the same, when making Punnett squares, it makes a big difference, right? It makes a big difference if you're double capital or if you're a mix, because double capital can never have a blue-eyed baby, right? Even a double capital with a blue-eyed wife can never have a blue-eyed baby. But when you carry that side gene, when you're this mix of capital and lowercase, you can have the blue-eyed baby, right? And so this is why in the beginning we said you have to know the genotype. Knowing the phenotype isn't enough, because if I look at you and you have brown eyes, I don't know if you're this brown, double capital B, or if you're this brown, right? One capital, one lowercase. Because if you look at the crosses, same situation, brown eye dad, blue eye mom, but this one on the left never can have a blue-eyed baby, whereas this one on the right, they can have a blue-eyed baby 50% of the time. And so if you want to do this for fun on your own, if you want to cross you and your boyfriend, or you and your girlfriend, or you and your celebrity crush, whatever you want to do, you got to know if you have this blue-eyed gene or not. And the only way, if you have brown eyes, you can really know is if one of your parents has blue eyes. For example, my dad has blue eyes. I have brown eyes. But since my dad has blue eyes, I know for a fact that I carry this blue gene, right? So I would be this example on the left. My mom has brown eyes. My dad has blue eyes. So I've got brown eyes, but look at all these babies. They all have brown eyes, but they all carry that blue gene. So I know that I carry this blue gene because my dad's got blue eyes, and so I know he had to pass a little B on to me. So what about hetero and homozygotes, those words we talked about? Well, those are important because what those mean, homozygote, this word homo means same. So something is a homozygote if it has the same two letters, two capital B's, that's the same. Two lowercase b's, that's the same. Those are homozygotes. That word hetero means different, right? Heterozygotes have two different alleles. So you got to watch this. This can get confusing because when it comes to homo and heterozygote, big B, double capital, two lowercase b's are a group. And the combo, capital lowercase, is the outlier. Whereas when it comes to phenotype, it's the opposite, right? When it comes to phenotype, B, capital B, and capital B lowercase b are a group because they're the ones that give you brown eyes, and double lowercase is the outlier because it's the one that gives you blue. So don't mix those up. When we're talking about phenotypes, the capitals are going to go together because the dominant traits go together, and the single lowercase letters are going to be unique. Those are going to be the recessive trait. When it comes to hetero and homozygotes, the same letters group up, the different letters are apart. Okay, so you guys are going to go through this, answer all the questions. Just do your best. Mr. Halber is a very, very smart guy. If you need help, I'm sure he's more than capable of helping you. I will be back on Tuesday. I'll be here every day to finish out the semester. So these last 4 sessions, I will definitely be here. And so if you still need help with this when I come back, always a possibility. But check out the video, go through this. I know it's a little bit of a lot of work when you include the graphs too, but I think you guys will be more than capable of getting this all done. So do your best, get done what you can. Ask Mr. Halber for help if you need it, and I will be back to see you guys on Tuesday. All right, see you guys then.